All right, everybody. Our last presentation before lunchtime. I can hear some growling stomachs out there. Ore blend optimization for optimal mineral recovery. And we've got three presenters, and they're going to introduce themselves. But just to tell you who they are, Ryan Littlewood, Jeff Armstrong, and Professor Giorgio De Tomi. Come on up, please. Hey.
Good to go? I think so. Leave a countdown. Is this the cord? Thank you, Charles, and your awesome accent. Good afternoon, everyone. My name is Jeff Armstrong. I'm the Director of Industry Solutions for Improving Toronto, and we are here today to talk to you about an ML project that we are embarking with our Brazilian partner, based around ore blending and the recipes sending to the mill to optimize the end result and standardize and get a consistent result from the mill. With me today, we have Ryan Littlewood, and he's going to speak a little bit about the company. We've recently made a big change. Some of you may have known me or our company as Jump Analytics in the past. In fact, we registered for this conference as Jump Analytics, and we are about a month and a bit into our acquisition by a company named Improving out of Dallas. We're also honored to have Professor Tomi here with us from the University of Sao Paulo in Brazil. And he's representing our Brazilian partner, Aura Minerals, who we did this project with. And it was him and his research team who identified this opportunity with the mine site. And we're going to go into that a little bit later as well, identifying the opportunity, which is a great segue into a roundtable discussion that I'll be leading tomorrow into: do you need ML? Do you need AI? And how to identify those opportunities? So with that said, I'll hand it over to Ryan.
Sweet. Yeah, thanks, Jeff. Like Jeff mentioned, some of you might have known us as Jump Analytics, but now our new name is Improving. So who is Improving? We're an IT services firm that is geared towards changing the perception of the everyday IT professional and their day-to-day. As a company, Improving operates 18 offices across North America. You can see that we put a little star next to Toronto because we're here representing Improving Toronto. And we also operate across 5 service lines, which include, obviously, software dev and consulting. So on the next slide, like we mentioned before, some of you may have known us as Jump Analytics, but since then, we have been incorporated into the Improving brand, which is a 13-time 500 over 5,000 honor roll list recipient, which is America's track of the top fastest growing private companies held in the country. So as a company, we're very well known for our industry knowledge, and we are known for creating solutions and solving problems for our clients that are really tailored towards them hitting their goals, whether it's internally or a market goal. We have, as a team, expertise in a lot of industries, which can span asset-intensive industries, such as utilities and forestry. And we're also very well known in the mining world, having both in-house expertise in a lot of open pit and underground mining knowledge. And as a company, throughout our development and focus on continuous improvement, we've also created a global COE, or Center of Excellence, around mining, which incorporates a lot of machine learning, such as the items that we're going to talk about today. So now that we've kind of laid the ground for our transition between jump analytics and improving, Jeff and Giorgio are going to start talking about our on-site opportunity that led to this incorporation of machine learning. Jeff?
Can you hear me? Yes? Okay, so as you've seen, they are the smart IT people. I'm the mining guy, okay? So I know the problem. I'm working with them on the solution. So what happened was we came across this opportunity by talking to the industry. This particular operation of Aura is a mid-tier operation. So it's not that they have a lot of capital investment available. So although technology is one of the priorities, it's not the top priority there. So we had to find a solution that is affordable and that can be tailor-made for them. So that was the challenge. And we spent some time understanding the problem. And what we learned is that, first of all, they have lots of data that they don't use. And as you've seen with the discussion by Scott with the digital twin, it's the same issue. There is plenty of data. We don't use it properly. We don't know where it is, and so on. So the opportunity was to use that data, their data, to establish a proper recipe for blending. Not a big issue, technically, but it's important to understand the challenge they had and what we had to do to help them to achieve that. And the other challenge that we had was they had lots of manual data entry. So that was time-consuming and bound to have mistakes, right? So those are the challenges that we faced, and we helped them to find solutions. But you might be saying, okay, good, but why a university professor is talking about that? Well, the way we set it up was like a R&D project. In the later stage of R&D, which we take a solution already, an existing solution, and we made it work for them. We did development to make it mission ready for them. So in terms of TRL, we are talking about TRL 7 to 9, okay? So that's why we put it together as an R&D project to come up with a solution to these challenges that they had on site, okay?
So I know we talk about on-site opportunity, but it's also on-site difficulties or obstacles. I'll speak a little bit about the opportunity that we encountered, and of course, it blends into that obstacle because, yes, we have a lot of data. We had a lot of data at this site, but did we know how good it was in the beginning? What's the quality of that data? Of course, that's a problem in every analytics endeavor. During the process of the exploration, and I encourage every project to go through that exploration phase first, prior to committing to the final product, of course, we've encountered a lot of unknowns as well as a lot of bad quality data as expected. And that actually changed the direction of the project and the goal in the end. Part of that opportunity is we wanted to eliminate the bias of whether it's the mine planner, whether it's the scoop operators. There was a high turnaround, as there is in many different mine sites. Fly in, fly out, you get different personalities coming in for 2 weeks, different biased altogether. So with that, we wanted to build something that was consistent on input and consistent on output, regardless of who was operating, who was entering that information. Speaking of information, there was a lot available. We had your block models, all the geological information we needed, the stockyard and stockpile information, characteristics, et cetera, tonnage, ins and outs, and of course the mill, how it's operating, and its inefficiencies and efficiencies. What we decided to focus on, and this was because they had another project on the go, identifying, what's coming down the pipeline in the benches in the coming months. That project was going to create a 3D model of the stockpile. That wasn't going to be ready for us to use, so we had to go in and rely on the planners and the stockyard managers to tell us what's in that stockpile. So we're focusing on stockpile characteristics, lithology, grades, and tonnage, and a little bit about the mill as well. And I'll get into that under obstacles, I suppose. We're focusing just on recovery, what comes out of the mill. So with that, our solution required us to collaborate with 3 different groups. And those 3 different groups were the mine planners, so the person creating this ore blend on a weekly basis for the week or for the month even. The operators, the people putting the material in the crusher, as well as the drone operators who are reconciling those stockpiles. The 3 of them had 3 different data sources to work off of. And as you know, and unfortunately, those 3 data sources were Excel. Common issue, obstacle, whatever you may call it. So we decided to build our solution so that it brought all 3 together and one can operate without communicating with the other. Therefore, we provided a solution for the mine planners to understand and know what's in the stockpiles, and they can pick and choose from each stockpile for the optimal blend. And of course, this is biased or past experience. The drone operators would then use their image processing software, identify how much tonnage or cubic meters are in each of the stockpiles, and put that into our system as well. And then, of course, the scoop operators who are doing quite often pen and paper, tracking their scoop on an hourly or shiftly basis, we provided them that same application to document their operations. So with that said, we had all the information needed for our machine learning tool, our machine learning algorithms, to predict, based on historical information, what blend of rock, and we're talking at this particular site, they had 3 pits that they were gathering different ore from, and that ore had different characteristics, different lithologies altogether. And to throw a 4th in the mix, they also had a high grade, low production underground mine. So why not? What we did is we provided them that opportunity to collect the data, and that's, of course, step 1 of any exploration project. Identify where that information is, the quality of information, can it be used, and of course, machine learning needs and requires a lot of data points to be effective. So details of obstacles along the way, I'm going to have Professor Tommy comment on that as well. Not just data, believe it or not. I would say the biggest obstacle is people.
Okay, so like in terms of the challenges that we had on site, the top one by far was not technology, was not data, was really change management, the resistance to change. And it is understandable, right? They have their own process, they know how to manage it, and then it comes this group of university people, crazy Canadians, saying, oh, you have to change everything to be more efficient. Okay, so it was an interesting interaction, and it's something that we need to understand as technology providers, that we'll face it every time, especially in the mid-tier type of companies, okay? I'm talking about small scale and medium scale mining operations. They understand the opportunity, but they have difficulties to change their processes. So we had to put a lot of effort to make that work. And that effort is happening right now, okay? We are having success, but it's a lot of effort, and I tell you, it's much more difficult to manage that than to handle the technological solution. Because we have like a good partnership, we have good capabilities here in Canada helping us locally to make it work. But then we have to manage this change, and that's a big challenge. But like in general terms, we're doing well, right, Jeff? Because people are understanding, yeah, there is one thing that is important. One driver that is important that helped us to convince them is like this. They understand, of course, they understand the advantage of being more productive, you know, getting more bonus at the end of the month and so on. They understand that. So, okay, they talk to us. But then there is also another driver that is happening right now, is the fact that by being more efficient in productivity, you have better indicators of carbon emission, right? Because the carbon emission is the same, but because you're producing more, the carbon emission per ton produced decreases. And that was like something that helped us quite a lot in convincing the local people. Okay? All right, Jeff?
So I won't go into too much detail, but with regards to the machine learning that we used, we did choose PyCaret, and I believe there was a presentation before ours that mentioned low code, no code. It makes it easier for those to come in, and in terms of PyCaret, it works as a basket of, or a wrapper, including many different ML libraries. So it decides which one is most optimal for the data and the achievement that we're trying to reach. So with that, in this particular project, we are using a optimization done by a grid search. So if we do want to go into that any further or in more detail, we do have a booth set up by the courtyard, just at the door by the courtyard. Happy to ask or answer any questions you may have, and just, any other questions about this project. We'll all be there today and tomorrow. Now, in terms of this conference and the theme, just want to go over a few things, how we digitized their process, or digitized a lot of their data collection, number one. It was manually done, and of course, with the high employee changeover or turnover, there was a lot of bias being put into, okay, what's the optimal blend, number one. So the machine learning objective was to eliminate that and have anyone who comes in getting the same results. But we also provided that digital format or platform to enter in all the information that was previously done in Excel, and believe me, it's difficult to find all those spreadsheets when trying to collect all this data. The exciting part, of course, and every project I've been on requires improving or has that second phase. I mean, it is what we do. But looking to the future of this project, we'd like to incorporate a lot more data, and that's where that exploration phase really put us down a different road compared to the one that we were planning on going down originally at the beginning of the project. But we'd like to add in hyperspectral imaging that would improve the accuracy of the attributes sending to our ML, knowing exactly what's going into the crusher, into the mill through the conveyor. Of course, IoT sensors, we would love to have used a lot more of those in the mill. That's another data engineering project in itself, and what we discovered was, and it's like this for many historians, this one was on a secular database, so it was overwriting itself every 30 days. So it wasn't very achievable to look at historical information. And of course, further integration of the mine planning. So this information that we're getting could be sent to the mine planners and put into their systems to aid with the more accurate planning and future forecasting again. And of course, that's going to benefit the mine plan all around. And if we can incorporate the geological information from the block models, which we are now able to do now that that project is completed, that is something that we're looking to do in the future. And I do believe that maybe some of you have recognized the commonality or the very similar obstacles and challenges and maybe even opportunity at your site or some of your clients' sites.
Because I lived through that, okay? Interesting question, because what happened was we started with an as-is model. We had to take their processes and build a model for them to understand their own process. And it was very interesting because each sector of the operation understood their processes well, but didn't know much about the processes that came before or afterwards, right? So what we did was to build an overall as-is model, and that was very important to help us with the management of change. Why? Because we took this model and we worked with them on the opportunities to improve the current processes. So it became much easier to sell internally the changes that we wanted to implement. So this is the approach we took. It's a lot of work, okay? You know, it's not our job to build an as-is model, but we did that so they understood the opportunities and made it easier for us to sell the product internally.
Next question is, what were your KPIs? Do you have a min threshold for precision and recall? So we had very minimal KPIs, to be honest. Going into the project, again, going through that exploration phase, we did have some change of course. We were going to try to accurately predict what was in the stockpile by monitoring the fleet management system and the trucks, where they're pulling from, where they're dropping off, to the, you know, precision of 1 meter to 3 meters. We were unable to do that following a fleet management system source system change. So we decided to go with biased, I guess you can say, what the stockyard managers were saying were in the stockpiles, how much tonnage was there, and really relying on the drone footage and the accuracy of that. There remained 3 main KPIs that we're using for the machine learning algorithm, and that was grades, tonnage, and lithology. Lithology was important to us because of those 3 different open pits, and of course the underground, completely different lithologies, rock hardness, and that really played a good part in what the machine learning algorithm was telling the mine planner to do. And when we're saying the blend, we're talking like 3 scoops from this stockpile, 2 scoops from that stockpile. Over time, and it was done on an hourly basis, they would build the recipe via that through scoops. And then, of course, we would love to get more into the mill and understand the different circuits and how the lithology and the rock hardness is affecting each circuit. But the first phase of this project only dealt with the recovery and trying to standardize or optimize and make sure it's consistent. What advantages does machine learning have over standard optimized calculations? I think we discussed that in terms of bias. We're not expecting this machine learning. Every machine learning project I've been on is an experiment, and we're hoping that it works. And I've had many fail, and it's not because it's a machine learning issue, it's a data issue or data accuracy or just not enough quality of data. So we're hoping that this machine learning optimization recommendations is more of a advisor that they can tweak, and over time, of course, it's going to learn what is optimal. And that can be blended in with the operator bias. Could you please share some of the success metrics that you've established for this project, and how did you track the user adoption? Do you want to tag team that one?
Yeah, well, in the beginning of the project, we set up, they established a target of improving 5% of the throughput of the mill, okay? So we had to set, all the conditions for them to be able to put more material through the mill. How would we achieve that? With a better blending recipe. So that was the main objective of the project. And we put a target of 5%. We are tracking that. We are not there yet, but we are very optimistic that will be achievable by the end of the project, which is towards the end of the year, right? Okay, so we are still on track on that.
Right, so that's kind of a segue to the bottom question. What percent complete is the project? I would say we're in UAT at the moment. It's going to take time to collect the data. Of course, we don't have a ton of historical information. Therefore, the algorithms are going to have to learn on more recent, more current data. We're working on change management to make sure that they continue to use it over the next 3 to 6 months. But at this point, our hands are off development-wise, and it's only just feature enhancements as requested. What impact have you achieved? I think Professor answered that. We were looking for a 5% increase. Right now, we're looking for more consistent output, let's put it that way. They have a threshold of 5,000 tons per day. We're trying to exceed that by making the whole process a little bit smoother or quicker. If we can achieve 5% more throughput, I think that's a win. And maintaining a consistent recovery was the ultimate goal. And the exploration phase did change our target of, achieving a consistent recovery rather than full-blown more input or more throughput. Why didn't you use commercially available ML models and software? We did have a few discovery sessions on what can be used, how is it going to be economical to our client, but also skill set and integration with other tools that we're very familiar with. So we did choose and decided on PyCaret as it integrated very easily with all our other tool sets we were using at the mine site. How are the stockpiles at the mine constructed to make grade lithology? So because they had 3 open pits, they had, at any given time, 3 to 5 different stockpiles, low grade, medium grade, high grade, and then various lithologies within. That was dealt with by the mining team. I wouldn't say that was any of our responsibility, but the tool and the application that we provided understood what was there based on the information that we got from the drones. So it took into consideration, let's say there was, 1,000 tons in the high grade, but 10,000 tons in the low grade. They wanted to prioritize using low grade to get it moved and processed. We provided that ability to really, ensure that 1 or 2 stockpiles were used in the algorithm, in the recommended blend, or leave out a stockpile. Maybe they want to use that for end of quarter, end of year. But really it was up to the mine site to organize their stockpiles. When you define the project scope or business processes, redevelopment, people training and change management part of the scope? Or did you discover the need as you work through the challenges of the project? Challenge number 1, I don't speak Portuguese, so thankfully we had a great partner and team under the University of Sao Paulo to help us coordinate with the mine site. That was a challenge, and we mentioned before the employee turnaround and secondment, people changing jobs on the fly every 2 months in the middle of the project. The scope, yes. We had these stage gates. Again, I stressed the explore phase to identify the goal of the project and can we achieve that. And then people training. We had video training, we had document training, and then we went to Brazil once. We were going to go again to deliver the solution and do some more training then, but we opted out of that. It's occurring kind of remotely, which is great. Improving Toronto is spread across Canada. It is just a name, but our operations have employees everywhere. So it makes it easy to do just online training, video conference. And that's it. Any other questions? We're at our booth all day. Thank you.